We have a packed schedule for the next 3 days, covering research and innovation tracks and also showcasing our works from all the streams from our institute, starting from IMTechs to PhDs in the open house the third day. Today there will be PhD colloquium and innovation track focused only on the students. Tomorrow there will be a session which is focused on the startups from the Innovation Center. Third day will be the open house. That's the schedule of the RISE. We hope to have fruitful sessions and some useful outcomes to the PhD students, especially today in the PhD colloquium, and some interesting ideas to crop up from the tomorrow's sessions. And we hope to have a very nice open house as well. I welcome you all once again for this edition of RISE, and I request all your cooperation. We now request our Dean Research, Professor Srinath, to give few comments on RISE.
Good morning. I was actually hoping to just sit in the background today, but I'm standing in for our director today, who was supposed to be making this address, but unfortunately he sends his regrets because he has come down with some bad throat infection or something, so he's not unable to reach today. So let me kind of give some background of the RISE colloquium, especially for those of you who are attending it for the first time. We started this colloquium 2 years ago. I think Professor Shiva has been spearheading this colloquium since then and doing a very great job of. So as part of the colloquium, initially we thought of this more like a outreach program, where we showcase what we are doing to the outside world and so on. But as our experience from the last 2 years has basically told us that it's much more than an outreach program. It is actually a churning program. That is, this is a program that brings together different facets of the institute as well as its connections to the outside world, right? And puts them on a platform to create the necessary changes in this thing. So as we keep saying, the universities are basically not training centers but ecosystem builders. So they're basically meant for creating well-rounded professionals who are not only good at their technical skills but also problem-solving skills, critical thinking skills, and social skills and interpersonal skills and so on. So in a way that they should be able to take on tomorrow's challenges, right? And this is where a very critical element of the university experience comes in engaging with different kinds of modalities in which we engage with the outside world, right? So we think of research as something where we develop new ideas. So the entire colloquium starts with the research colloquium first, and where new ideas are developed as part of the university curriculum and process and so on. But then a lot of it is an applied or of an applied nature. So we consciously strive ourselves not to get into the ivory tower paradigm, that is the usual refrain about universities sitting in their own ivory towers while the rest of the society is facing a lot of challenges. So we consciously tell ourselves that we develop new ideas, but at the same time they have to see the light of the day, right? And that's where innovation comes into the picture, where we actively encourage our students to be well grounded in their ideas, well grounded in application areas, well grounded in social issues, and address these challenges and so on, and come out with solutions that can be taken out to the outside world. And we also engage with society in different ways. So we engage with industries, we perform sponsored research for them, we kind of take on consultancy for specific problems. We even sit on their boards sometimes and try and look at technical advisory boards and so on. We also engage with governments, NGOs, and in different ways. So unless we bring them onto the table here, innovation and research really would not be well rooted, right? And so that's another essential element of this colloquium. And finally, of course, entrepreneurship is where most of our energetic students go there. And, so they really don't want to join an existing system, but they want to create new systems and create. So they really don't want to be job seekers, but job creators tomorrow. So this is a platform that is bringing all of them together, and it has been meticulously designed over at least the last few months by several faculty members. Perhaps Professor Shiva would be able to acknowledge each one of them in detail. So wishing this colloquium all the best, and let me not stand between you and the rest of the colloquium anymore. Thank you once again.
Thank you, Professor Srinath, for those kind words. And I request our Dean Academics, Professor R.C., to speak now.
Very good morning to all of you. And I'm actually filling in the big shoes of Professor Sadugopan. And if you look at the schedule, he was going to give a talk on building responsible citizens of the future. I was sure I would not be able to do full justice to that topic. So I carved a small subset out of it and then say, what does it make to be a good technologist? So what I felt was, this is something that even when I was with HP earlier as a solution architect, so many young developers and designers used to come and approach me saying that, what does it take to become an architect, right? And it turns out when I was reflecting back upon that advice that I used to give versus what I'm going to be talking about now, there seems to be lots of similarities, right? So not to belabor on the other point, we used to say that you should go for a T model of skills wherein you have lots of very wide range of skills to be an architect with depth in at least one technology or whatever. Right? So that is essentially an architect. But since I have come into the academia, my perspective has slightly changed in terms of what does it take to be a good technologist. So when I was looking around for inspiration, so to speak, it turns out that this has been thought about, right? Already saying that what does it make a good engineer, right? So all of you must have heard of the Washington Accord, right? So for those who are not familiar, Washington Accord is essentially an initiative, if I can use that term, mainly to define interoperability of engineers across the world, right? So we have engineers in every country is producing so many engineers. Needless to say, I don't even have to remind how many engineers India is producing. So there was a question saying that, what defines an engineer? So when I'm looking at an engineer, somebody with a BTech degree or an MTech degree, or for that matter, even a postgraduate or a research degree, how do I compare? So this whole Washington Accord initiative said that, okay, let us come up with graduate attributes which define a good engineering graduate. So I'm going to take the liberty to extend that to any technologist, right? So it need not be an undergraduate, graduate. So I'm not making any such distinction, right? So what I will do is I'll quickly list whatever has been said as part of the graduate attributes, and then I'll try to map it to how we are trying to do it here at IIIT-B and my own views on how these graduate attributes can be met and inculcated, right? Needless to say, one of the first graduate attributes people talk about is knowledge, right? So we need to have good amount of knowledge, and the Washington Accord itself goes ahead and says that it is not really focused on any one particular discipline. In fact, it very clearly starts with the classical STEM elements of education. So it says mathematics, good knowledge of mathematics, good knowledge of science, right? And then it says you have to have obviously very specialized knowledge in engineering discipline, right? So we can imagine, right? So if you are going to claim as being a technologist or even an engineer, obviously knowledge is of paramount importance. So that is something that shows up first. And then it slowly, very nicely goes on into elements of how do you make use of that particular knowledge. So that they have elaborated into multiple facets. For example, problem analysis, right? So the ability to identify, formulate, analyze, and solve problems. Because this is something that we also, all of us, keep emphasizing in our courses, saying that yes, it is good to have all this knowledge, but can you develop the ability to spot problems? Right? Even knowing the problem is sometimes a big challenge. So many people, it doesn't even bother them to say that, okay, there is a problem to be solved here. So the first is to be ability to identify problems. And of course, once I think many of my PhD students would be able to identify, we all keep saying, right, half the problem is solved when you identify the problem. Right, so that is a very, very important ability that is part of the graduate attributes. Of course, once we have identified, then we have to be at it to formulate, analyze, and solve that particular problem. Okay. The third element, which again, which is something that in IIIT-B you hear quite a lot, is about the curiosity levels, right? Of course, all these are not orthogonal, so each one influences and depends upon the other elements. So, for example, right, so to be able to identify problems, you need to have enough amount of curiosity, right? So, if you are not curious enough to be able to tinker with something and break something, then obviously you will not be able to identify what are the problems that are out there, right? So, experimental and curiosity mindset is deemed to be an essential. All these graduate attributes I'm talking about are essential, right? So necessary, and we're not even talking about sufficiency here. These are all necessary elements of graduates, right? So investigation, right? The ability, the curiosity mindset and experimental mindset, right? Of course, once you are able to conceptualize the problems themselves, it should not, the complexity of the problem should not hold you back in terms of thinking about big solutions, right? So which is where from the research context, we talk about incremental research versus path-breaking research versus, so of course, not everybody have to or has to or is able to do path-breaking research all over the place, but we have to strike a right balance, and which is why we always talk about when we, even for incremental research, we want to make sure that there is significant amount of additional contribution that is coming in. So which is where the complexity of the problem should not hold us back, and it should drive us forward actually, right? And this is where the slight difference between the engineering aspects of it and the non-engineering aspects of it comes into the place. So here we are saying that yes, you are able to think about the problem, you are even able to design the solutions, but of course you need to be aware and you need to learn all the engineering tools that are available, especially with the right tools for the right job. So which means this is almost emphasizing the point that it is not good enough just to think about the big thing, big problems and so on. You have to develop the ability to use the tools and use the right tools for the right job, which also means that it is not necessary that we have to solve all the problems from first principles, right? So while we always encourage that, don't jump into the tools straight away, those who have taken my classes, I'll tell you, right? So I don't want to see people doing C programming with using an Eclipse IDE, right? Having said that, unless you know the intricacies of that particular technology, you need to have tools to be able to scale to address complex problems, right? So if you are keeping on adamant that, Professor RC said, no, don't solve everything from first principles, it's not going to, you are not going to be able to solve and complete those big complex issues. Of course, right mix of individual and teamwork, and I think the theme of, I really love the theme in which the RISE event is set up, right? So while we are talking about the PhD colloquium, it is all about individual work, right? So wherein you are looking at some complex problem, trying to figure out a solution and so on, but then we are augmenting with, with innovation and entrepreneurship. So which is all leading up to how do you work with others in a larger ecosystem and produce solutions as which can again go back to analyzing and solving problems. Communication skills, I don't have to belabor this particular point, because the idea is that it is the moment you're talking about teamwork and solving complex problems, it no longer is the problem of an individual, right? So it requires us to, and again, right, so I'll keep on reminding that what is it that we are saying, and we are looking at the graduate attributes, right? Which means what we are saying is it is just not about trying to boil the ocean by yourself, which is not going to happen. So what we are saying is, so communication skills here is essentially about your ability to communicate with different stakeholders. We are just not talking about our own colleagues or your own colleagues or your own peers. We are talking about different stakeholders, people who might be as part of the problem space or the solution space. As part of the solution space, you have to collaborate, which is something that I'm going to talk about next, right? So you'll have to collaborate with multiple kinds of technologies to arrive at a solution. Similarly, you'll have to talk to multiple stakeholders, right? I think Professor Srinath mentioned about, so many of us are involved with government projects, and the number of different stakeholders that are involved in solving a state level or even a national level program is huge, right? So which means the ability to communicate at an appropriate level using appropriate medium, right? Here we are not even talking about only speaking skills or writing skills, right? So any which way you can, with which you can communicate with others. So this is where slowly we are getting into other aspects, saying that sure, you know all the great knowledge, you have excellent knowledge, you are able to crack problems, you know how to work in a team and so on. But then it also comes with the responsibility, which is on the professional and ethical side of things, right? So with it is now more than ever, there is a lot of importance that is being looked at from an ethical perspective. With the ability, with the capacity of technology increasing so much, so the onus is on the technologies to make sure that it is used in an ethical way. In fact, IIIT-B has recognized its importance to the extent that in the last 2 years you can go back and see our graduation oath, we have changed and we have included elements of ethics into it, right? The ethical and responsible use of technology, right? Aware of impact on society and environment, right? So this is another thing that, in fact, my other colleagues from the IT and society would definitely be able to corroborate, right? So even from the early days of computers itself, one of the it was probably not a red flag, an orange flag that was being raised was all the potential environmental hazard that any technology brings in, more so the computing technology on the electronic side of things, right? All the way from starting from the use of mercury into making those components to the responsible disposal of all these equipments, because by design it was generally accepted, right? Even it's very strange that even our financial auditors acknowledge the fact that these electronics equipments are will last only for 3 years, right? They acknowledge it by acknowledging the fact that you can write it off in your books, right? So if it is known that all these things are going to last for only 3 years, you can imagine if you are talking about a sustainable technology spread over multiple decades, if not multiple centuries, what is it that we are talking about, right? So we are talking about, if you're, within a span of 100 years, you can imagine the amount of electronic e-waste that is going to get generated. So how do you create technologies which are sustainable, right? Right, ethics, ethical use of knowledge, economics and project management, I will talk about that as well, which means it is not just about the ability to create solutions, solve problems, it's also the ability to do that in a very cost-effective manner, which boils down to the impact on the society as well, right? Which means we cannot be creating solutions which is going to cost a bomb, right? And the last attribute, of course, is very beautifully put, saying that it is lifelong learning. I think the fact that, again, I myself personally motivate myself, saying that if my friends from finance can acknowledge the fact that a computer can be thrown away in 3 years, what about then my knowledge that I have gained in the last 3 years? Is it still going to be relevant, or should I keep reinventing myself, right? So that is essentially, and these are all the 12 essential graduate attributes as given by Washington Accord. But I have taken the liberty to say that this is something that all of us as technologists should imbibe, saying that this should be what we should aspire for, right? So, so there is absolutely no, in each of them it is a continuum. It is not a very fixed set of courses that you can do and put a tick mark against. So that is on that note. So I want to slightly switch into the way we have been looking at technology at IIIT-B, and which kind of very nicely reflects the way we look at. So again, I'm a multidimensional kind of a guy, so I keep talking about multidimensional models in wherever possible. So I have tried to create 3 dimensions, right? So one is from since anyway we are talking about technologies and engineering and things like that. So I will start with hardware as one of the dimensions, right? So if you look at the classical engineering disciplines, say the mechanical engineering, starting with mechanical engineering, because if you want to use the Industrial Revolution as a reference for the development of the engineering discipline itself, so it was all mechanical, right? So we had very, very extensive mechanical equipment which is intended to solve a lot of the problems, make things efficient, scale up, right? All the good things that engineering, mechanical engineering, and those allied areas which played a very key role in the Industrial Revolution. So they were all extremely hardware centric. They said that, okay, let us get this done, right? So slowly when computing came about, they said that, okay, so far the technology, whatever engineering has focused on, doing big things and moving big rocks and constructing big railroads and constructing big aircraft and stuff like that. So slowly when computing came about, the second dimension was born, which is essentially the software aspect of it. Correct? So people started focusing on solutions which were highly software oriented and things like that. I don't have to give any introduction to all of you on what is happening on this dimension, right? So that was also, I think, if you look at the Indian software industry itself, right? So the whole Indian software industry is thriving on this dimension, right? So, but what is interesting is in this 2-dimensional coordinates, now things are slowly beginning, saying that we are no longer getting things which are exclusive on one dimension, right? Slowly now people have figured out, saying that there is a lot more that we can do by appropriate mix of hardware and software, compared to doing something exclusively with hardware and completely exclusively with software, right? So I'm sure all of you are able to relate to it, saying that today if you look at what were traditional hardware, let me just take a simple printer, right? The good old printer, the dot matrix printers and the line printers, they were all extremely, they were just about hardware, right? So it was all, even if you take one more step behind the invention of printers or typewriters, right? 100% mechanical, right? Slowly software elements were brought into it, and so that is where now when you talk about printers, maybe you will say that now slowly now we are able to position technologies in this 2-dimensional axis, saying that printer is probably here. It used to be here, it started moving here. Right? So it is still a whole bunch of bulk hardware which is sitting there, a lot of mechanical parts that are in there, yet there is enough amount of software that is being put. Now what is the evolution there, right? We started from pure typewriters to to printers, dot matrix and other printers. Slowly we are moving towards what are, right? So when we, this evolution is now called MFD, multifunction devices. Right, so now we are saying, okay, now you know you can now no longer print, you can scan, you can copy, and in fact, when I have been part of solutions where I was able to create an application, install it on the printer. In fact, I think Dr. Ramani is going to be here. So as part of HP Labs, he built a beautiful solution wherein to authenticate paper documents. You know, the solution was very interesting, right? So you create a, right, you take a land document or your own degree certificate. So the degree certificate is encoded. I think this was, I'm talking about more than 10 years ago, right? So it may look a bit, you can take it for granted now, but at that time, so you had a 2D barcode kind of an image on the document. So the whole idea is, how do you authenticate that particular document without anything else? Which means I don't want to connect to a master database. I don't want to send a mail to IIIT saying, is he a right guy? Is he a graduate from your institution, and so on. So the whole idea was, you create a secure encoded 2D barcode, 2D image as part of the certificate itself, and this is where this part comes in. So as part of the HP printers itself, you scan it, you put it up on the scanner. All it will do is it will decode what is there in a secure manner. It will decode what is present on that particular 2D barcode and spit it out. So I have what is the information that is supposed to be there, what is the information that is already being produced as an output. I compare and then right there, completely offline solution. But then that is made possible by intelligent use of hardware and software and the ability of that hardware to run that software, right? So things keep going. So the message for me here is that we should, the days of exclusive solutions along these dimensions where one of the coordinates is 0 is gone, right? So you are invariably going to encounter solutions all over the place, right? So sure, fair enough, it can be here, it can be here, it can be here, and so on. So what I'm trying to say is that we have to look at utilizing the innovations that are happening on the hardware world and make sure that software is able to live up to it. I think, as always, the race between the hardware and software has always been ahead of the curve, but that is something that we have to be very conscious about, right? So, and of course, if you look at the 45-degree angle, which has got equal amount of hardware and software, so all of that, today we talk about, any thoughts? What could be fitting in the 45-degree angle? Robotics, thank you. Right? So we talk about right? So we have all of these things which are which means every solution that you have to look at in these two dimensions. Now I want to introduce a third dimension, which is, okay, so this is not the diagonal, so I have to, okay, so this is the third dimension, is the society. Right, so this is very much coming from the graduate attributes that we saw. So the message here is, yes, it is great to build great solutions, which is a combination of hardware and software, but then, right, what is its relevance to the society? Right, so what kind of real problems is it going to solve? Are we creating technology for the sake of creating, or are we trying to solve some problems which are out there, right? So which is where the third dimension will bring in. So this is, which is very nicely within the theme of this particular conference. So that is where the innovation and entrepreneurship is coming into the picture, right? So the third dimension is a constant reminder to you that don't create technologies for the sake of creating technology, but make sure that it is solving a problem and its own impact and things like that. So this is where you might be having your own flashback of your interviews with the venture capitalists and business people and so on, saying that what is it that you're going to do, how many people is going to impact, and of course they will also say how much money it is going to bring in, but fair enough, right? So let's say there's no society without money, which means, so this is the third dimension that has to be incorporated when you think of technology. And I think what I like about this particular model is you can keep on adding more and more dimensions to it, right? So the fourth dimension can be cost, right? So which can nicely frame a sentence in this four-dimensional coordinate geometry, which means how do you use an appropriate combination of hardware and software to solve a problem of the society in a cost-effective manner, right? Similarly, you can bring about fifth dimension, right? So how do you make it accessible? So today we talk about inclusiveness and so on. So you take the fifth dimension in there, right? So there are multiple ways in which you can look at what role you can play as a technologist, and I think this is a wonderful platform. So I think the small mental exercise we should do is we should take all the talks that are being presented here, and not all of them may be strong on all the three axes, right? So we'll have solutions which are maybe research. I would imagine PhD problems will probably be only in two-dimensional axis without the third dimension. Maybe, right? It's okay. It is perfectly fine for that. Whereas when you talk about innovation and entrepreneurship, definitely I will bring in the third solution, and we have to look at it from that perspective. Okay, so that essentially is what I wanted to share with you, saying that what does it mean to be a good technologist, and how do you position yourself as a good technologist? And if you want to claim somewhere that you are a good technologist, probably you can just create a whole bunch of two-dimensional and three-dimensional points and say, yeah, I'm a good technologist. Thank you.